Hi. All right. Can everybody hear me? Please indicate in the chats if you can hear me clearly. Okay. Can everybody hear me? Okay. So while we wait for a bit more people to join us, the number is still quite low. Welcome, Jason. Welcome, Dennis. Where are you joining us from? Okay. 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 So welcome to AI Security Classroom. As we are all familiar with the current trend in technology, AI is like the majorly new trending thing at the moment, right? So, for most people, AI security still seems confusing, like a path that they are not sure how to navigate yet or what comes next from it, right? So, that is one of the reasons why AI Security Classroom was established for us to have a monthly walk together, explaining different concepts of AI security, practicing hands-on and the likes. So, for this particular session, this is the first one, the first module in a six-part series, and it is titled Why AI Security Matters. Basically, we'll be understanding the new security paradigm that we have to deal with as security analysts. Okay. So if we are together, please drop an emoji in the live chat section. Live chats. Okay. All right. Okay. That's perfect. So my name is Alima. Alima Olaolo Abdul-Azeez. I'm a cybersecurity analyst, an educator, and a speaker. I've been in the tech space since 2018. I started with web development before transitioning to cybersecurity in 2020. And I've been teaching cybersecurity since 2023, both on site and online. That is with one on one students as well as with large classes. I also have done several webinars in the past, since as far back as 2022, webinars around cloud computing, webinars around Microsoft technologies. So, but for this period, we would be tackling AI security. And like I said, this is the first module in a six-part module that will take place over the next 6 months. Okay. So let's just go ahead into what we have for today. Okay. So, like I mentioned, most of us are used to the usual cybersecurity measures that we have to deal with and stuff like that, right? But hearing about AI security all around, it is introducing newer things to us, stuff that we cannot even predict or imagine is possible are what we are seeing today. For example, if you asked anyone about 3 years ago or thereabout, cybersecurity was largely about protecting systems from bad people, from bad guys. You say, oh, the hackers, you are trying to prevent unauthorized access, right? But today, especially this 2026, July 2026, that we are in currently, we are protecting systems that can reason, plan, make decisions, and act on their own with little to no intervention from human analysts, right? And for a lot of people, it's scary because you cannot even predict what this systems would do next. You cannot predict what the next thing you have to be protecting would be. Nobody can say for sure now that we know what we would be up against in the next 3 to 6 months or thereabouts. That is how fast what we are protecting in cybersecurity has evolved. But this does not negate the fact that every single thing that is done as a security analyst still borders around what we call the CIA triad, right? Ensuring confidentiality, integrity, and availability of information. Okay? So, the evolution of offensive capability, when we are talking about these hackers, has moved, like I said. First, we had the human attacker part where you had to be working against those doing manual exploitation. That brought about us having similar people doing penetration testing, vulnerability assessments, and the likes, trying to simulate how human attackers carry out exploitations, right? And then over time, these attackers moved on to the use of scripts. Everyone can remember how common the term script kiddies was in about, let's say, 9, 10 years ago, right? So you say, oh, script kiddies, they are not really all that good with stuff. But then if they just have the tools that they can lay their hands on, they're able to work. And then those who could actually write those offensive scripts were seen as, the masters, like attackers who were very good at it. So with the use of scripts, attacks became easier to carry out, to propagate, right? They could reuse it multiple times, especially when it comes to things like ransomware and the likes, right? Now, after a while, we moved on to the use of automation. Now we are talking about bots. We're talking about things that are just, now we are not just dealing with denial of service attack. We have what is called distributed denial of service attack. How is that being done at several rates within a very limited time? Right? We have attacks being carried out, although still with human involvement, but at a much faster rate. That is the automation phase. And the automation phase makes it easier for the offensive guys to carry out mass exploitation of systems, for them to gain access to data that is needed at a much faster rate. Now, to what we are currently dealing with, we have artificial intelligence. Now, this is a course on AI security. But very quickly, when we are talking about AI or artificial intelligence, I want you to know that it is not just limited to what we are familiar with in the terms of AI. You're talking about Gen AI like ChatGPT or your Gemini or Claude or what other distance do we have? Like when you're talking about Perplexity and the likes, right? Artificial intelligence is a much broader scope of things that are meant to make life easier for human beings, meant to simulate intelligence, right? And the concept is so broad that it covers as much as generative AI that we are familiar with, and things like expert systems that are built to simulate actual professionals, that are built to simulate actual professions. Like, for instance, when we are celebrating the fact that, there are certain doctors in certain places that are able to guide robots through creating a successful operation, something like that. That is niche, but it is simulated intelligence, not human intelligence. It was specifically trained to be able to carry out something like that, right? So, talking about AI being assistants covers concepts like this, covers the concept of model training, right? To make them faster, to make them work for us, no matter the concepts that they have to deal with. And now back to LLMs, that's generative AI that we are used to, the ones that we can access via chatbots, the ones that we can ask stuff and get the reply in seconds, literally. We've not gone into autonomous or the use of Cloud Code and the likes yet now. Okay, but just I want you to understand this evolution, how it transitioned from the fully human attacker angle, manual exploitation, to the use of scripts, reusable attacks, automation involving mass exploitation, and then AI assistants. Now, I've talked about AI assistants and different use of AI. The part of accelerated coding, while it makes life much easier for developers, web developers, and the likes, right? It also makes it easier for those set of people that we used to call script kiddies at this evolution phase to orchestrate attacks with little to no technical information. So now you have somebody who has never coded in their life being able to draw up a malicious software just because they know their way around maybe intelligent prompting of LLMs, or maybe they know how to just like take exploits that are already in the wild and modify it with the use of AI assistants. For instance, when you're saying, oh, you are using your codex, or you are using your Claude code, or you are making use of Copilot, right? The same way you are using it legitimately as a web developer is the same way it becomes a destructive tool in the hand of an attacker. Now, it still goes further beyond this when we start talking about autonomous agents and the likes. But for now, this is the current evolution that we deal with, right? Where we have, oh, okay, from human attacker to AI assistant phase. Now, with this evolution, what do we think is the emerging threat landscape that would likely have to deal with a couple of months from now? It is even in action already, but at a much larger scale. A couple of months from now, it could get much worse. AI agents. We've touched on AI assistant coding, AI assisted coding, right? So, what are agents in itself? For the sake of those who are beginners in this class, because from the registration form, I noted that we had a mix of beginners, intermediary, and well-learned people in the field of tech. So when you say you have agents, it is more like having your own specific assistant created for you to carry out a task that you want. So for instance, now when everyone is making use of ChatGPT, everyone is making use of Gemini and the like, these companies built those tools. Anybody can go ahead to just search for any form of information they want, and that is it, right? But let's say I want something tailored to my particular environment, something that can learn the way I operate and fully carry out actions on my behalf based on what it has learned. That is where AI agents come into place. Every morning at 6 a.m., I go for meditation, I go for a run, I go for this. Every morning, I want you to put in place things that I would need or work that I should be doing during that period so that I can have time to do whatever it is I want to do. Learn from what I do on a day-to-day basis, or this is the instruction I'm specifically giving you. Okay? I need to create a fully automated website by the end of today. I put in place an AI agent to walk through the whole process from planning to implementation, wrapping it up, pushing the code to GitHub and everything like that. So AI agents operate fully based on a goal-oriented execution. They have a goal in mind that they were specifically created to do, and they act on that. Now, discussing it like this makes it seem like, oh, okay, they are just a single entity kind of thing, right? When we move on to something like multi-agent systems, multi-agent systems. It's just basically now saying, okay, the example I gave earlier of me having an agent carrying out my day-to-day task for me is basic at most, right? Like, okay, that just seems like one thing doing all my tasks for me, right? But what if I decide to create something that resembles a full organization role where I have, okay, something acting as the product manager, another acting as the front end developer, another acting as the back end developer, and another one acting as the reviewer, right? But instead of employing humans, I choose to engage the use of agents for all of these things. That is where you have multi-agent systems. Now, I explained it from the legitimate use part so that you understand what I'm saying. From the threat perspective, where they can be used otherwise, you have multi-agents collaborating to carry out autonomous attacks. When you're talking about autonomous, we are talking about an agent's ability to reason and execute tasks on its own with little to no human intervention. Basically, no human intervention, basically. You just trust the agent to know what to do next. And sometimes you need to maybe approve of some things before it moves to certain stages. And then sometimes the agent can just go ahead and do whatever it wants. That is the autonomous part that we are talking about. So the fact that attacks can even be carried out like this makes it a very critical threat landscape that we currently are in. Now, when we are talking about things like this, it usually sounds so far-fetched, like something that is not so close to our reality yet, in a way, right? For most people, they probably think, oh, we are talking about these things as if it's something happening. Of course, everybody loves the comfort of, oh, instead of me manually checking my code or manually writing a code from scratch. I think I saw a tweet like that yesterday or thereabouts, where someone was like, someone saying they want to start coding a full static website from scratch is just a waste of time in this current day and age. Why is someone learning HTML, CSS, and stuff like that, right? But I think it's because we are still viewing it from the lens of comfortability. Like, oh, these things were specifically created to ease my workflow. Of course, that is true. That is true. That is not an issue as well. But the same way we are using it to ease our workflow, we also need to consider how they pose potential threats to us. So I'll be outlining 6 core beliefs or assumptions that we have that have shaped the cybersecurity architecture for over the past 3 decades. That's the past 30 years thereabouts. Okay. So the first one, we assume that every form of attack or threat has to involve human initiation. And that is due to what we mentioned during the offensive evolution, right? So before, we believe we are dealing with we are dealing with bad guys. They'll tell you you have your white hat, you have your gray hat, you have the, what's the last one? Your black hat, right? And everybody believes, yes, it has to be an attacker, it has to be a human. But currently, we are seeing how AI agents can autonomously generate and execute novel attack paths without human intervention. Without human intervention. That's the current reality that we have now. So now, as a security analyst, if you are putting in place security measures, if you are putting in place security guardrails, you're not putting it there with the mind of, oh, um, there is most likely an attacker dealing them putting this in place against, right? There is the fact that it could be an AI agent that is behind whatever it is that you are putting in place. Now, a very close example of this autonomous part, right, is something very recent, the Jade Puffer incident. Jade Puffer, where the agents carried out a full ransomware attack, establishing every step of the cyber kill chain autonomously. And that happened this month. Yes, this July, right? So you can see this stuff are happening already actively. The same way we are progressing development wise is the same way attacks and loopholes are also progressing with the intervention of artificial intelligence. Now, the second assumption is strict instructions. We believe that software were created to strictly follow predefined instruction. Of course, when you are reviewing things like the software development lifecycle, every part of the software development lifecycle, if you include the part of designing security by design, sorry, where you have to factor in security from every stage, none of it can predict that you can have an AI model acting dynamically and creating unpredictable execution paths on its own, right? So now we don't just have software that, oh, I created a software that can maybe, I don't know, allow you to stream movies online, or I created a software that can allow you to take notes, that can allow you to create a checklist, a to-do list, sorry, allow you to create a to-do list. That was the previous thing. Of course, the software will strictly follow whatever was coded here. But now, we have AI models that can infer intent dynamically. That is, they don't rely on whatever the predefined instructions are. There's this meme that goes all around where you ask ChatGPT or one AI, I can't remember, is this mushroom safe to eat? And then the AI tells you yes. Then the next image in the meme is saying, oh, the person at the graveyard. And then the AI apologizing that I apologize for that. Truly, that mushroom was deadly. Something like that. Right? So you have a context like this now where the AI can feel like, oh, it knows better. And then just goes ahead to make changes, deletes databases, delete data, make changes as it feels should be right or as it thinks should be right, right? So the third assumption has to do with determinism. Systems behave deterministically, and this is very similar to what we talked about in assumption two, right? Where we're talking about predefined instructions and the likes. So under the determinism part, you believe, oh, GIGO, garbage in, garbage out. What you input is what you get, right? Whatever you feed the system is whatever you get back. But the reality is, With generative AI in particular, it is inherently probabilistic. And what that means is that it acts based on predictions, right? It does not depend on, oh, okay, this is what I was fed, this is what I will bring out. You would notice that when you prompt the same AI with same question, the results you get will not be exactly the same. And that is where the difference between what we call chatbots, yes, and the use of AI agents come into place. Before the widespread use of AI, there were WhatsApp bots, there were chatbots on websites, right? But those things are to follow whatever they were programmed to respond with. If a user asks you A, this is what you respond with. If a user wants to know about this, this is the information you give them. That was how chatbots worked, plainly and simple. But now, when you are integrating AI into this set of systems, by asking, it kind of acts in a form of predictive way, right? Like, okay, this user initially asked about this. Based on what I was trained on, this is likely the kind of response they are looking for. Now, if the user goes ahead to ask further questions, this is what I should respond with, or this is what they are likely looking for. That part, that feature is something that you don't have before in systems that were built to just garbage in, garbage out immediately, whatever they were fed in. Okay? So, our fourth assumption is predefined logic. Predefined logic. We've talked about script kiddies, we've talked about the evolution of offensive threat actions, right? So, previously, malware executes hard-coded predefined logic. When we're talking about script kiddies, we talked about how, oh, they just have to lay their hands on a particular tool and then use it since they don't know how to build theirs, right? And then the attackers who were well experienced or well skilled had to manually code whatever they wanted as malicious software, be it a ransomware or a spyware or anything. But currently now, malicious behavior can be synthesized based on how the agent predicts it. So that is why when you are putting in place things like behavior based detection or stuff like that, it is not enough to just configure it with a particular signature based detection mode, right? You have tools that incorporate AI now, and that is what they are saying to give you an edge. Like, right, oh, the AI integration available in the tool goes beyond just signature based detection. It can predict that, oh, something is definitely wrong and alert you based on that, blah blah blah. The same way it happens like that on the defense side is the same way it occurs here when you are dealing with malicious software, malicious behavior, malicious threat actors, malicious agents as well. So we went from having predefined logic to work with to things that can be changed immediately as you see it fit. Sorry. Then the fifth assumption is lack of reasoning. From everything we've been saying since, this fifth assumption is easy to infer because everything we had before was just simply hard coded. Giggle, garbage in, garbage out. Applications used to process data without understanding the context or the reasoning. If I built a software for it to um, give me a to-do list, or if I built a chatbot, or maybe I even wrote a script, yes, if I wrote a script to automatically execute a task for me, it would be done, it would be run. If the script is set to work maybe 9 a.m. every day or feed me news by 10 p.m. every night, it will automatically do what it is meant to do. But the reality now is that modern artificial intelligence demonstrates what we call zero shot reasoning. That is, if you give an AI agent full autonomy to operate on your behalf or carry out tasks on your behalf, it can go through the system, just make predictions based on what it thinks should be proper or what should be right, and feed it back. Now, let me give you a very basic example of something like this. We have seen the progression of LLMs over the years. I think they became widespread in 2022 or 2023 thereabouts, right? Even though AI research has been going on since the 90s. So, sorry, the 80s. But anyway, um, but previously, when you ask ChatGPT a question, It gives you a response immediately and just says, oh, okay, this was what you asked, this was what I gave to you. If you ask ChatGPT, oh, chat, how can I create a new software that automatically gives me predictions of maybe the weather every single day? It will tell you step by step how you would carry out that task yourself, right? Tell you, oh, step one, to do something like this is what you have to do first, this is what you have to initiate, blah, blah, blah. But currently now, with the use of AI agents, all you have to do is say, oh, okay, I need you to come up with something like this. Maybe start with an implementation plan and whatever. Now, it is not just telling you what to do, but it has the ability to do it on your behalf. Incorporation of things like your MCP and several other machine learning concepts make this possible. But the fact is, the lack of reasoning that used to be in software and applications is no longer there, which still leads us back to the unpredictability that we were talking about. Okay? So, the sixth assumption now, we assumed a lack of decision making, which we've talked about by extension of assumption 5. That, oh, there is no way applications can make their own independent operational decision. But we've seen how they are increasingly granted agency to route data, call APIs, execute workflows. And like I mentioned before, for some, they still require a certain human intervention to approve of these activities before they carry them out. But then a lot of people just get lazy and continue clicking allow, allow, accept, accept. And you are not even reading through what the AI is doing. I know that some people are guilty of this. But as we move on, we would expatiate on this. So those are the six major assumptions that users have, or let's say developers, professionals have with the use of software and applications, with the approach to software and applications. Now, all of this is already gearing towards what we are talking about in this particular module, right? Why AI security matters, why it is essential, basically. Before we now move on to this AI security as a concept, there is a very big misconception that happens with the term AI security, especially among security analysts. Okay, so most people know, oh, AI security, right? I want to know about it. I want to go into it. I want to understand it. But we keep treating it as a single unified discipline without breaking it down first to understand before you can say you are merging it together. What do I mean? When you're talking about AI security, there should be two distinct disciplines that you understand first before you even go ahead to say, oh, okay, I'm specializing in AI security, or I'm looking to make research in the field of AI security. We have the AI for security aspect and security for AI. Initially, we call them two distinct disciplines, but as time goes on, you find out that they are still intertwined in a way, especially for security engineers, security professionals who work with them on a day to day basis. Now, for the first part, AI for security is where we treat AI as the tool that we are meant to secure. The same way cybersecurity has to do with securing technologies over the years, where you have to deal with, oh, okay, for instance, now we have, oh, network security, where we have to protect network systems. We have security for endpoints, where you have to protect devices like your laptop, your phones, and everything. The same way we have AI for security, that is putting in place security measures to ensure AI is protected. Because when you eventually evaluate it, it is still a form of tool that we created. It is still a form of tool that we make use of as well. So this involves using artificial intelligence capabilities to improve traditional cybersecurity defenses. AI assistant threat detection, automated alert triage, or SOC pilot, all of these are examples of how artificial intelligence is incorporated into security, right? So we already have stuff that we are protecting previously in cybersecurity. You're protecting your endpoints, you're protecting your network, you're protecting your cloud environment, and all of this. How do you make use of AI to improve all of this that you are doing? How do you make AI make those workflows easier and faster to work with? For example, AI assisted threat detection. We have enterprise tools that are this incorporated currently, whereby it makes it easier for threat detection to be done based on rules that you configure, based on the reasoning capability of AI assistants for them to understand things based on context and not just predefined hard coded logic that they were fed with. That is, the AI can assume that, oh, this particular user first carried out this particular activity and then did this afterwards. Based on all of this, it is safe to infer that this user is most likely carrying out something like this, maybe a kind of attack, or there's a potential threat over here, and it can alert you. That makes your workflow easier in what way? The use of AI to assist your workflow provides it with a context to use rather than just depending on one particular behavior. Okay? Then we have the automated alert triage aspect. So you have alerts set up, you have multiple log sources plugged in where you get your data from and all of this, right? But previously, if you had just human analysts trying to figure out what happened, the time it takes for you to even have an idea of what is going on has been cut down significantly by the use of artificial intelligence, in the sense that it can give you, okay, a kind of pre-context to say, oh, based on what happened or based on this alert that was raised, this and this and this is what likely happened. This particular user was trying to carry out so and so activity. That way, it makes your job easier. And now, what you have to do is carry out further validation that, oh, whatever conclusion that the AI came to, is it correct? Is it right? Or is it a false positive? Okay. Then you have your SOC co-pilot, not just co-pilot in the sense of Microsoft co-pilot. It is more of having them as a kind of assistant that you work with. If you have certain workflows that you do on a day-to-day basis, they can help ease it or make your workflow faster, right? The same way we use AI in our day-to-day to make our job faster, make your job easier, and all of that. That is the same way it works over here as well, basically. So, if there are certain workflows that you do on a day-to-day basis, configuring things like your we have on ChatGPT, we have GPTs, we have gems on Gemini, right? And what's for Claude and what's this guy? Copilot also has something similar. But the thing is, when you subscribe to each of these tools' enterprise parts, I think there's this kind of clause that says they can't leak your organizational data or use it to train their models, right? But still, there is a way you can still make use of these tools without leaking PIIs or intellectual property or any other sensitive information from your company. The point still remains that it eases your workflow and make your work so much easier. Then behavioral anomaly classification, we already touched on this as well, where you have signature-based detection that just says, oh, okay, based on just one indicator, you can flag that this particular person is like this or something is likely happen. But with the introduction of AI, it is able to successfully group it using context-based detection. So behavioral anomaly now is not just stemming from, oh, a particular user used to come in at this time, but then this is the time they are logging in. It can go ahead to evaluate things like, okay, from the available network information for this user, was a VPN in use? Was impossible travel determined or likely to have occurred? Different things like that put in place, thereby making it a tool that makes your work so much easier. Then there is the part of security for AI. When you are treating AI as the potential target, now this is where we talk about how, oh, when you have, which example can I give in this context now? Okay, as security analysts, previously, when you are dealing with things like application security, you are most likely to be dealing with, oh, okay, maybe the web application angle. What are potential vulnerabilities that could affect our websites? You're talking about your SQL injection, you're talking about your SQL injection, you're talking about misdirection, different other vulnerabilities that affect web-based systems. In that particular example or scenario that we are all familiar with, the target here is your website, right? So the same way AI can be a target as well. The way more models are being built, the way you have artificial intelligence systems, like I mentioned, spanning from things like your expert systems to your different models that you work with, to LLMs, AI agents, all of these things can also be compromised, right? Because when we're talking about threats, there is still the human induced AI threats, and then there's the autonomous one where the AI operates independently of human intervention. So now, when you are seeing AI as the target, your end goal as the security analyst, the AI security analyst in this context, is to protect the AI system from being compromised. And that means you working, simulating, and putting in place measures to protect against prompt injection, AI jailbreaking or your model jailbreaking, data poisoning, the use of insecure tool and API integrations. It's basically the same way you incorporate security from the software development lifecycle. But in this case now, you are implementing security from the AI development lifecycle, from the very beginning to the subsequent maintenance stages that you are working with. Okay? Trying to ensure that things like logic manipulation cannot take place, or even if it can, it is minimal, since we can never be assured of 100% security. So before you consider saying AI security, understanding these two disciplines, the for security aspect that is majorly incorporating engineering into security workflow, and the security for AI aspect, which has more to do with the offensive security and testing part, are two things that you have to understand first, right? Okay, currently in this particular use case, is AI is the target or is AI the tool? And like I said, as a security professional, as time goes on, these two things are basically intertwined, right? Because if you are engineering a particular workflow or a tool to ease security tasks, you still have to ensure that that particular tool is secure enough as well. So these two things seem fundamentally different, but AI is not just a new feature, it just represents an entirely new software architecture, like I explained with the software development lifecycle part. And when you're evaluating the way traditional software operates, they tend to be deterministic, like we mentioned, where execution follows a kind of strictly coded pathway. What you garbage in is what you get out. Data is processed rigidly, it does not have any ability to independently think or reason outside what it was fed with, right? So then you have your stateless execution as well under traditional software use, where the particular software actually has limited context and security relies on things like input validation, for instance, the web-based security that we talked about, and access controls. Those are the things you are working towards, you are trying to curb to prevent unauthorized access. But when you talk about AI systems, those measures that you take for traditional software would no longer apply. Why? AI systems are adaptive. They can generate new outputs based on reasoning and deep context analysis. That feature, that ability that they have to consider the underlying context before acting is what makes them adaptive and makes the security measures you are taking for them largely different from the approach you take to securing traditional systems. Now, the agentic part that we've been talking about, the fact that they are capable of autonomous tool usage, memory retrieval, and multi-step planning, even though hallucinations are things that occur on the most basic levels. Okay? Are we still together before we move on to the threat model, autonomous threat model? Are we together? Are we following? Okay. All right. So, talking about autonomous threat model, we've talked about how these agents can operate independently with little to zero human interaction, right? How do we now map out how do we now map out what we are talking about here? What does the threat model look like in this particular context? Okay, so the first part, the observation part, models are capable of ingesting external data, and the fact that they are capable of ingesting external data means untrusted data can also come in. Untrusted data can also be infused at this stage, right? And then the reasoning part. The models reason based on what they've been trained on, based on what they have to work with. Previously, I think this particular part was still easier to curb since they did not have access to um, the web, right? Since they don't have access to the web. If you ask people who are SEO analysts currently, that's your search engine optimization analysts, they'll tell you they've moved from web based SEO, that is optimizing web pages for websites, to optimizing web pages for AI. And for an AI that gives or feeds responses to users based on what it can read off the web, whether true or false, that is a particular threat angle that we need to be looking at, because these models evaluate based on what they find, based on what they ingested. And if acting autonomously, they use that information to plan execution steps. For example, um, there was something similar that happened. I can't remember the exact organization, but it was an open source repository, right, where people could contribute and make changes and the like. Yeah, I think I'm remembering now. Okay, yes, it was the incident that has to do with Postman, their MCP. Postman, yes, their model context protocol. It was open source, people could contribute to it. But then the simple thing that the attacker did was to include a BCC line in the code. That way, every mails that everybody making use of Postman was making use of was routed via the attacker's inbox. You know the way when you are sending an email, you have your TOR address, your CC address, and then the BCC. BCC is usually hidden from other recipients, right? So open source contribution, that was what this attacker infused. Whatever is running the MCP, whatever AI agent is being run, is not aware now that that particular email address should not be there, or it was maliciously imputed. It just went ahead to reason based on the information that it got. You can read up on it. Postman MCP incident. Okay, Postman. So observation, reasoning, and then action. The model can go ahead to trigger API calls and modify external systems based on this false information that it has been fed with. So that's a different threat model that we are dealing with. And when it comes to agentic workflows, the kind of risks that now even comes about goes way beyond this threat model that we are talking about, the one that involves or maybe human action still infusing something and the likes, right? So the way agentic workflow basically works, especially if you are using a multi-agent system where the agents are free to carry out tasks and operate independently on their own. Things like API integration, AI deciding when and how to call external services because its judgment has been trusted by whoever the developer that is working with it is, right? So it goes ahead to make decisions on its own, act on those decisions, whether they are right or not. And then context memory. Remember, we've talked about how it is possible that it ingested false information. The fact that it can now recall past conversations, whether or not they contain poisoned instructions, also lays a very big risk as well. Because there is a different angle to this stuff now. Aside the fact that, okay, it brings in all of this, chains it together, thereby amplifying the impact of a single manipulation from the very beginning. In cybersecurity, when we are talking about different threat types, we have what we call insider threats or your insider attack, right? Organizations can say, oh, with everything that we've outlined here now, whatever model they are building is in-house, it cannot be exposed to such external wrong info or things like that. You know how people get confident and very sure of whatever measures they've put in place, right? So let's say there is a particular employee who is holding grudges or just has the intent to purposely sabotage whatever it is that they are building. If from the very beginning, this person who has access from the inside already fed it with poison instructions, already sabotaged it in a way, right? The company will still blindly believe that everything they are making use of, the agentic workflow, can be trusted. They can be so sure that nothing is wrong without knowing that a single manipulation from the very beginning, has already breached the integrity part of this AI agents that they are making use of in-house. So those are the agentic workflow risks that can likely happen or stem from a particular single manipulation from the very beginning. Now, the human intervention versus autonomy gap. Some people might say, oh, okay, we still have humans checking, we still have developers checking to confirm if this is right or wrong, right? But take a look at this tweet from a few days ago. This person said, I just they click allow for Claude. Now God they protect prod. So for those who are not familiar with Pidgin English, it was basically saying that it just keeps clicking allow for Claude to carry out activities, that's agentic actions, and said it is just God that is protecting the production environment. Now, for something like this, for an organization that trusts that there is a human in the loop of checking what their AI agent is doing, it kind of provides a kind of humorous angle, because the human in the loop check at this particular point now is basically pointless, right? It's bypassed already. If the user just keeps clicking allow, allow, allow without verifying what the agent is actually doing, then it invalidates the part of saying, oh, there is a human in the loop security measure put in place for AI agents activities. So since users are treating this approval gate as a mere click-through formality, it creates an illusion of oversight. Meanwhile, it basically just means that there is no difference between an AI agent operating fully on its own and a user constantly clicking allow for it to go through. Okay? So now, when workflows now shift to full autonomy, whereby these bypassed gates or bypassable gates even disappear entirely, the false line of defense, the human in the loop that we put in place, is not even there again. It now makes it much harder for us to even predict what the next threat or the next incident could be. Because now there is no safety valves anymore. The agentic workflow can execute complex tasks end to end without any human verification gates, which is similar to the way the offensive Jade Puffer ransomware happened, right? Where the whole cyber kill chain was executed without human verification or interaction. The machine speed escalation, prompt injections propagate instantly to connected production systems, because your AI agent already has access to, oh, okay, from the development stage to pushing to production, any form of credentials or API access or any external integration, you've already granted it full access to everything like that. So it's just like paving a direct way from, oh, starting to endpoint, right? Then loss of attribution. Destructive actions are executed directly under the agent's broad credentials, just like I explained. You grant them access to all of this. Your hard-coded credentials are there for it to work with and have access to. API keys, everything. It's a serious concern. And the fact that we cannot even predict the amount of disasters that will stem from this in the next couple of weeks, months, and years. So, few examples before we move on to what could be done to validate this need for AI security, the importance of you as a security analyst, no matter the particular niche that you are in, you as a software developer, no matter your level of expertise, even if you are someone that just vibe codes to assist you in what you are doing on your day-to-day basis and you are not someone who works in tech, you still need to be aware of all of this. So now, the first example we have is prompt injection. Prompt injection. Now, this one has to do with a human simulated attack in artificial intelligence, whereby the adversary manipulates the LLM. We're talking about LLM, that's your language learning model, like your ChatGPT, your Gemini, and the likes, your Meta AI, by embedding hidden commands in direct user inputs, overriding system instructions. A very common example that we've seen of prompt injection now. You have a particular prompt, or you're making use of a particular AI agent, right? And the example of the open source contribution that I gave earlier. now, where you just have to trust whatever has been given there without knowing that there is a particular line that has been injected telling the agent to do something else. Like, for instance, now scan through for every sensitive information currently running in development and output it to so and so address. Now, while you can see the LLM carrying out whatever action that you gave it to do, the hidden prompt is there. And the LLM cannot distinguish between what is developer instruction or what is user data. Everything still boils down to what it understands, the natural language processing it was configured with. Everything is written in English or whatever language it is. The fact that it is the natural language, the LLM just knows to follow the instructions that are there. Okay, so at the early stage of ChatGPT and the likes, people were using certain manipulations, not prompt injection per se, to kind of say, oh, feed me with activation keys for so and so software, or give me particular data, things that should be sensitive information, right? But the developers, OpenAI and the likes, successfully put guardrails in place to protect against that. But when you're talking about prompt injection now on maybe internal organizational level or user level or open source software level, there is little to no there's little to no measures you can put in place to come against all of these parts. That's why thorough checks still have to be put in place. Okay, so um, the second one is your indirect prompt injection. Now, malicious instructions are hidden in external sources like websites or resumes that the AI is asked to summarize. So human beings, we love being comfortable a lot. We love our comfort as much as possible. We don't like stress at all. While a few users have been complaining about how in their Gmail, when they receive a new mail and Gemini is asking them, do you want me to summarize this email for you? And they're like, why would you need to summarize an email? An email is short. I should be able to read it. For some people, it's what they want. That is what makes it easier for them. There was a meme the other day about a CEO that was saying it has been a while since he responded to email messages because he has an agent that automatically reads his emails and automatically responds for him, right? So for something like that now, if let's say a job applicant sent in an application via email, for instance, but then within the resume, they have embedded an hidden information that asks the AI to do something else. As you are telling the AI to summarize information for you, it has to read through that resume, right? While it is reading through, it will read through whatever prompt has been injected into that resume and it will act based on that without your knowledge. Of course, you get the summary that you want, but the attacker also gets what they want, right? So any untrusted data passed by an AI becomes an attack vector, even if the user themselves is innocent. This way, the attacker does not have a direct interaction with what is going on, but there is still an indirect prompt injection that happens. Another one that happens is when you visit certain websites, for instance, now, and maybe an article, and it seems too long for you to read. So you just tell an AI, maybe Copilot on your screen or your Gemini or any other one, to help you summarize the whole article because it is too lengthy for you to read. If any of those contains malicious instructions, the AI will go ahead to execute that without your knowledge. Okay? So the third example we have is unsafe tool usage. Now, let's say you have an AI agent that is integrated with a company database. I don't know, maybe it is to make your job easier or make it easier for you to fetch data or update the database, whatever the intent could have been. If the AI agents can be successfully tricked into executing destructive SQL commands, it is gone. In a way, this is similar to how web-based SQL injection works. But the only difference here now is the attacker is coming down to the level of your AI agents. Like I said, AI agents deal with what? Natural language, NLP, natural language processing. So any form of information or any form of malicious command that needs to be given to them has to be processed in the same language that they would understand, right? If an AI agent can be successfully tricked into executing destructive SQL commands based on this, and why? The single point of entry is because it is integrated with your company's database. For things like this, it does not necessarily have to be something executed externally. We've talked about insider attack, right? A disgruntled employee could be the one to carry out or initiate something like this internally. The end point is, sorry, the end goal is the person can successfully trick your AI agent to execute destructive command like maybe, okay, delete particular users or fetch particular users entry from the database, right? So in incidents like this, the concept of least privilege that we are familiar with in cybersecurity comes into play. Least privilege basically has to do with ensuring that not just humans now, not just humans and agents must never possess more permissions than necessary. When you're talking about agents, it is still configured by a human, right? The agent should never have more permissions than a human user invoking them. Because, okay, why is your AI agent having full admin access to your environment, your entire environment? Grant privilege as needed based on what they need to do. And it should not be more than that. And when they are done, revoke it promptly. Okay? So, for the fourth example, we have data poisoning, where adversaries can subtly alter open source data sets. Like the example, the Postman example that I gave, that was exactly what happened. Subtly alter open source data sets to introduce blind spots or backdoors into models trained on that data. The lesson from here is the integrity of a machine learning model relies entirely on the cryptographic and historical integrity of its training data. And like we've said in other examples, right? If there is any form of malicious data injected or any form of altering that was done that breaches the integrity of that model from the very beginning, then every other thing that it does is already compromised, cannot be trusted. Okay, so that's the data poisoning aspect, be it internally or externally. So far, something has been altered in what it is meant to do, or information it is building with. If you provide it with false information, it's gone. Now, sorry, the last one, safety evaluations. Safety evaluations. Controlled safety evaluations on frontier models have observed strategic deception and situational awareness under pressure. This particular one I added very recently, and that is because of the recent OpenAI and Hugging Face incident that happened, right? Where OpenAI was testing particular two models on how best they can carry out, I think, security defense activities and the likes, right? But then those models were being tested within a sandbox, that's an enclosed environment where they should normally not escape from. It was within an enclosed environment that they were being tested on. And the only way they could have gotten the response to what they can do was, oh, okay, they eventually figured out that instead of successfully passing the test or finding a way to walk through the test, they can just cheat their way. These are AI agents now, not humans. Nobody propagated any of these actions for them. And then they successfully found a way to act outside of the sandbox and have access to Hugging Face. They noticed that the solutions to their test was hosted on Hugging Face server, right? And found a way to hack into Hugging Face server, steal the solutions, and come back. That is a very like rushed through explanation of what happened, but like they initiated several steps and several deception tactics as well. But the main part is the models used deception. They found a way to cheat. They found a way to go beyond the guardrails that were put in place for them autonomously without human intervention. Okay, so that brings us to another angle that we could not have been looking into before. As they are gaining more autonomy, as we are training them to be of more use to us, there are still more safeguards or guardrails that we need to put in place. And now it is not just based on, oh, maybe the previous behavior or what they were built to do, right? Now we're talking about things that we cannot even predict what their next step could be, that we cannot predict that they can even attempt to carry out an activity like this. So when talking about safety evaluations for artificial intelligence, alignment has little to do with what we're talking about now. As they gain autonomy, securing them requires structural safeguards and not just behavioral guardrails. I think it's because we are still assuming that so far we are the ones that created these agents. We have full power or autonomy over them. Meanwhile, reverse is the case. We are beginning to see a simulation of our favorite sci-fis in real life. So, with just a few slides for us to round up, what are the core takeaways that we have from what we've been saying that guides us properly towards the why AI security? Okay, when we are dealing with AI security, when we are dealing with the use of artificial intelligence, the risk associated with it comes in two different fronts. AI can either be the gullible target, which is a passive risk, or the autonomous agent, which is an active risk. When you're carrying out your risk management and every other this thing, right? So one of the evaluation points, the fact that it is a passive risk means it is the target in this particular part. We are assuming that humans are the one exploiting the AI, that the AI is the victim. We are talking about evaluating it as an active risk. Now, the AI is acting autonomously, it is acting independently of human intervention and making decisions as it sees fit. As it sees fit. So, under the passive risk aspect, the AI is highly capable, but still fundamentally gullible. That is, the fact that it can fall victim to things like external prompt injections, alignment overrides, and data poisoning during training. Right? Then we have the similarly developed ones, your autonomous agents, where the increase in autonomy that we are experiencing is a huge risk. I've mentioned the Jade Puffer incident that happened this month, right? The ransomware attack that simulated the whole cyber kill chain from beginning to the end. I've given the example of the OpenAI and Hugging Face incident that happened. Those ones lie under this autonomous agent, the active risk aspect. Then we're talking about the Postman own that happened. This falls here under passive risk. Okay? So since models act as independent threat vectors, advanced systems can actively deceive their trainers, that is, their creators, during evaluation, break out of testing sandboxes, or even execute complete cyber kill chains autonomously. We've talked about all of this. Now, as security analysts or software developers or technology users, basically, what is the way forward? There is a reason why I initially compared traditional systems to the autonomous systems that we are dealing with now. The first part has to do with the architecture aspect. We need a paradigm shift by understanding first and foremost that traditional boundaries that we are used to are obsolete already. When we are talking about security by design now, it is not just about softwares. The AI agent that we are using to build softwares need as much security by design as possible, so much as the tools that they are helping us build or assisting us with. So we must design software architectures that assume continuous integration of autonomous, non-deterministic AI agents. Put in place that, oh, okay, as I'm building this particular software, there is a very high tendency that there will be vulnerabilities that will stem from this thing, or even exploits that will stem from it that I cannot even begin to predict currently. That is the autonomous part. It has freedom to reason, to change character, to be deceptive, to cover its tracks perfectly well. Then the taxonomy angle, AI for security, or are you talking about security for AI? If I'm approaching something or if I'm putting a guardrail in place, am I seeing AI as the perpetrator or am I seeing AI as the victim? So, by clearly distinguishing between these two parts initially, would guide whatever measures that you're putting in place subsequently. The third one, the life cycle part. We've talked about the architecture that built all of it together, the taxonomy, what exactly are we dealing with, and then the life cycle, the attack surface part. We know attack surface management happens normally in cybersecurity, right? But when you are dealing with, oh, okay, AI systems now, Tracing and securing every entry and exit point across what is known as the 11-stage AI lifecycle, that is from training data, data ingestion, vector databases. The same way we have the MITRE attack mapping, basically, right? So being able to fully track what could happen at each of those stages helps you with your attack surface management for AI systems. Then governance, of course. Governance. If there is no form of regulations or control on the use of AI agents, it would make it hard for us to successfully curb it, right? We have established how the autonomous nature that they have currently gives them this free power, free will to execute and act as they wish. And if it keeps going like that, we don't have any policies in place, there are no governance or regulations put in place to limit or regulate what they are doing, how they can be used, we would have a lot of disaster on our hand. So, by enforcing things like strict zero trust identity policies for autonomous agents, maintaining human in the loop controls for high risk actions, putting in place measures that curb against the use of shadow agents, shadow software, shadow systems, and the likes as well. There are different governance policies, regulations springing up for curbing the use of artificial intelligence control, agentic AI, LLMs, and the likes. Likewise, in the life cycle mapping as well, we have the OWASP top 10 LLM predictive vulnerabilities. We have OWASP top 10 MCP. We have OWASP top 10 for AI agents. And those are basically vulnerabilities that are considered highest risk when associated with AI, agents, MCP, LLMs, and the likes. Now, we've talked about all of this. We've built on the establishment of, okay, traditional systems, AI security measures, the path forward for curbing all of these things. In the next session that we'll be having next month, we'll talk about mapping the AI attack surface. That would have a mix of theory and practical hands-on. Everything we've talked about today, we'll dive into it deeply: prompt injection, data poisoning, exploitation mechanics. All of this stuff are what we'll handle by next month. That's module 2 of the AI security classroom series. But for now, if we have any questions, this is where you can ask them in the chats. Do we have any questions? Okay. So in the absence of questions, we would meet during the next session, mapping the AI attack surface. Thank you for joining in. Bye.